Let us look at the next section, students. This section contains 4 questions. Each question has 4 options, out of which only one single option is correct. So let's start with question number 32. It says pyrrole is a heterocyclic compound and its structure is given as. Been given the structure of pyrrole. In the presence of acetic anhydride, it reacts with nitric acid to give the product X in high yield. So we have to identify the product X. So if we talk about this reaction condition, students, there is acetic anhydride and then there is nitric acid. So students, this acetic anhydride is going to act as a dehydrating agent. It will remove a water molecule from nitric acid to give us the NO2 plus. Okay. So there will be the formation of nitronium ion, and now this nitronium ion will be attached to this pyrrole. Okay. So this is the electrophile, and we know that if we talk about pyrrole, there can be 2 possibilities of the electrophile getting attached. So the electrophile can either attack at this position or it can attack at this position, and depending upon the stability of the intermediate, we're going to have the major and the minor compound. Okay. So if we talk about the attack at the above position, okay, if we call this as 1, this will be 2 and this is 3. So if we talk about the third position first, so in the third position, if the electrophile is attached over here, then the plus charge will be at this position. And if we talk about the second position now, students, if the electrophile attacks at the second position, we're going to have the formation of this intermediate. And we can clearly see that out of the 2 formed intermediates, the one which was formed below has more number of resonating structures. Okay, so this is more stable because of the more number of resonating structures, students. So this will be the orientation of the attack of the electrophile. So the nitro group which will be attached will be at the second position. Okay, so students, for this question we have to mark the answer as option A. Let's look at the next question now. Question number 33. Consider the following reaction sequence. So we have been given this compound. It is first allowed to react with PCl5 in excess. So students, the PCl5 is going to convert all these OH into Cl groups. Okay. So if you talk about the compound P now, the compound P is going to be this compound. Okay. Further, P is allowed to react with dimethylamine in excess. When it is allowed to react with dimethylamine, students, so Me2NH. So all these Cl groups will get substituted from the acyl carbon. Okay, so we're going to have the formation of this compound. Okay. Further, it is allowed to react with LiLH4 in presence of H2O. So it is going to give us the amine. Okay. So this is the compound R which was formed. Now this R is allowed to react with MEI in excess, students. So there will be methylation happening. NMe3 positive. Quaternary ammonium salts will be formed. And now this quaternary ammonium salt will react with Ag2O moist in the presence of heat. So we have Ag2O moist in presence of heat to give us the Hofmann elimination. Okay. So we're going to get the formation of this compound, students, and we can clearly see that this compound is the compound W, which is an isomer of benzene. Okay, there are 6 carbons and then there are 6 hydrogens as well. So we have to identify the statement which is correct. So option A is not correct. W is not correctly represented in option A. Okay. If we talk about option B now, W upon acidic hydrolysis and heating will yield benzene. So we'll look at it a little later. Okay, let us look at option C now. W cannot give bromine water test. So this is not correct statement, students. Bromine can add on these double bonds. So W will decolorize the bromine water. Okay. If you talk about the last option now, W can show nucleophilic aromatic substitution reaction on reaction with HNO3 and H2SO4. So this is also not correct, students. This will not be able to show nucleophilic aromatic substitution reaction with nitric acid and sulfuric acid. Okay. So option D is also incorrect. So the only correct option is going to be option B, students. We can Just look at the conversion. Okay, so when this compound W which was formed is allowed to react with H plus, okay, so the H plus will attack at the alkene, okay, and then we're going to have the formation of the structure. Okay, so there will be ring expansion in this case, and upon ring expansion we're going to have this compound, and then the double bond will be formed over here again. Okay, next any one of the other two alkenes left will get protonated. Okay, the carbocation will be formed at this position in order to release the angle strain, so there will be ring expansion happening, and then we're going to have the formation of a 5-membered ring. Okay, and then there will be loss of another proton to give the alkene. And then a similar step of protonation and deprotonation will happen along with ring expansion to give us the benzene. So students, if we talk about the second option now, the option B is correct. W upon acidic hydrolysis and heating will yield benzene. So this is correct, students. So for question number 33, we have to mark the correct answer as option B. Let us look at the next question now. Question number 34. In which of the following reaction the product and reactant both have equal number of carbon atoms? Okay, let's talk about the first reaction now. So we have cyclohexyl alcohol. It is first allowed to react with PCC. So the product P is going to be cyclohexanone, and then when it is allowed to react with CH2N2 in presence of heat, the carbene will insert and give us a 7-membered ring. So students, the number of carbon atoms has increased in this case, so this is not going to be an answer. If we talk about the second reaction now, we have an amide reacting with P2O5. So the P2O5 is going to dehydrate this amide to form the cyanide. Okay, so if we talk about the product R first, the product R which will be formed is CH3CH2CN. Okay, this is R. R is allowed to react with H3O plus in presence of heat. This is going to form the carboxylic acid. And further, when it is allowed to react with NaOH this is the soda lime decarboxylation. So we're going to have the formation of ethane. So the number of carbon atoms has changed in this case as well. Let's talk about the C option now. We have this compound reacting with NaNH2. So the NaNH2 will extract this acidic hydrogen and generate a carbon ion which will then attack the CH3Br and make the Br group leave. So we're going to have the formation of this as the compound U. Okay, the compound U is then hydrolyzed in presence of heat, and then it is allowed to react with soda lime again in presence of heat. So NaOH. So just like the previous step, students, the cyanide will be converted into the carboxylic acid, and then there will be decarboxylation happening, and then the final product which will be obtained is going to be this compound. So we can clearly see that this compound has the same number of carbon atoms as that taken initially. This is the correct reaction. And if you talk about the last option in question number 34, students, we have the ester, cyclic ester. To be more precise, it is allowed to react with the Grignard reagent. So the Grignard reagent will cause ring opening in this case as it is a strong nucleophile. Okay, so this will be the product which is formed, and then when it is allowed to undergo hydrolysis and heat, this will give us this compound finally. So we can clearly see that the number of carbon atoms has increased by 1 in this case. Okay, so this is also not going to be an answer. Okay, so for question number 34, we have to mark the correct answer as option C. Let us look at the next question now. Question number 35. When the following ether E is taken in excess and treated with 50% aqueous ethanol. Okay, so the ether is taken in excess. We have to comment on the major product. So if we talk about the ether being taken in excess, students, there will be solvolysis. So a carbocation will be formed. So if we talk about the most probable site of the carbocation formation, students, we can clearly see that the carbocation is most likely to be formed at this position. So the lone pairs over oxygen are going to stabilize this carbocation which is formed. So this carbocation shall be formed out of the given 3 possibilities, and which will lead to the formation of this structure. and then the ETOH will attack over here and make this pi bond shift towards the oxygen atom. Okay. So finally we are going to have the formation of this compound. Okay. So if you look at the options which are given to us, students, we can clearly see that we have to mark the first option as the correct answer. So for question number 35, the correct answer is option A. Let us look at the next question now.